For this question, you should just justify the solution with a few good arguments, but it might help you to find out in a lot more detail why the object or the coyote is moving in a certain way. And when I was revising the mission, I realized that maybe that you might have problems following the track in the next chapter when I don't explain this in a bit more detail. So if you summarize what I'm showing in this video in a small text, that is enough for that question regarding the justification of the trajectory. So we look at the solution, at the situation where this is the cliff where the coyote is running with an initial speed of v0. And what we do here is, this is a method of reconstruction in physics that we haven't done before, and that's why I want to explain this to you, because this might already also be helpful in the future. So we don't know exactly how this will look like. So of course we have an acceleration that is pointing downwards. So this is affecting the velocity of the object. However, the acceleration is a change of velocity. We know that. But in this case, it doesn't affect v0 because it has an angle of 90 degrees. So the projection of vector A on vector v0 is 0. We had the situation before where v and A were like this. And then the vector A changes the vector v. It would be the same or similar if we had a vector v and a vector A. Then there would be, we had to find out the projection of vector A on vector v, which would be this one here. And only that part of vector A would affect the v in x direction. But there would also be an acceleration in the y direction caused by this acceleration. So in this case, v0 remains constant because the acceleration is only pointing in y direction and v0 is pointing in x direction. So what we do now, we try to make something like a stroboscope picture here, but only theoretically. So we assume that at the beginning there is no acceleration. So the object or the coyote will end up here after a certain period of time. So we just figured out that v0 has to remain constant because the acceleration only acts in y direction. But that means this acceleration is another speed in y direction. And now the sum of both velocity vectors is the total velocity. So the object after the second time period would end up here. Now, since we assume there is no other force acting in x direction, so the v0 is still the same. But since there is an acceleration downwards in y direction, this arrow will already be doubled. So the object will end up here after this interval. And again, v0 remains constant, but this vector is already 3 times as big as in the first place. So this is the vector v. This is the combination of both velocities, or the vector sum. So we do it another time, v0 and so if we look at the trajectory, we would have to draw a rather smooth curve around or over these points. Now, why is that? It is because we just set these time intervals in certain distances. However, we know that the acceleration is acting straight away and constantly, so we wouldn't have something like this with edges, as you can imagine, that all of a sudden it accelerates from by a certain value, but the velocity in y direction is constantly increasing. But since this is constant, well, we would have to decrease the distances of these time intervals and make them infinitely small. We've done that before in theory, but this seems to be rather complicated. So now we would have to, well, we know that this is a curve. It's not enough to really prove that this is a parabola. It could be another type of curve. So, but what would we have to do to really prove that this is a curve? Well, we look at the situation, and in a graph, we would have as y here, so the distance in y direction that we usually call height, and here we have the distance in x direction, which is called width. So we need to find a formula as y or as a function of as x, and this must have the form of a quadratic equation, or it must be a quadratic term, where as x is somehow squared as the highest power. And this is what we want to do in the following chapters. I'm just trying to find out if there is another way of showing that. I don't know if this works. This is a spontaneous idea. So when we look at the parabola, so when we go here about one step, we go up one step. Yeah, my drawing is not as good, but because we have 0 here and the point 1 lies on the parabola. So for 2 we have already height of 4. No, I can't see that this leads. No, it doesn't work. So maybe it does, but I don't see it. So yeah, so we will have to look for this formula, but for the justification that this is a curve, or at least that the trajectory that's shown in the film doesn't make sense, this should be enough. And if you find a few arguments for that out of this little video, that is enough for that question.